Hello friends, welcome to the video tutorial series by the Electronic Engineering Student Association ELISA of Walchand College of Engineering, Sangli. Today we are going to discuss on Shift Register, in which we will cover the serial in serial out mode, serial in parallel out mode, parallel in parallel out mode, and parallel in serial out mode. I am your facilitator, Mr. Mahadev Mishra, who are going to take this session. First, what is shift register? As we already know that flip-flop is 1-bit memory cell. But what if you have to store many bit of data? So to increase storage capacity, we have to use group of flip-flop, and this group of flip-flop is known as register. If you have to store n bit of data, then we require n flip-flop, and thus we call it as n-bit register. Okay. We have already discussed that shift register have 4 modes, that is serial in serial out, serial in parallel out, parallel in serial out, and parallel in parallel out. We are going to discuss each of these right now. The first we will discuss is serial in serial out mode. And in serial out mode there are two different modes, that is shift right and shift left. In shift right mode, data is inputted from left side and we will get data at right side. If you understand shift right mode, then you can definitely understand what is shift left mode. Okay. So let's consider the initially flip-flop having 0 0 0. Every flip-flop is having 0 0 0. Very important thing to consider is that the flip-flop which we are going to use in these shift registers are D flip-flop. And the truth table of D flip-flop is that whenever your clock is 0, no matter whatever will be your input, your output will be the present output. Means Qn plus 1 is equal to Qn. And when clock is 1, the output will be same as your input. And another important thing is that throughout this session we are going to use negative edge trigger flip-flop. That is, the input output will change only when the falling edge or down edge of the clock is occur. Okay, so let's consider initially all flip-flop having 0 0 0 0, and now we have to store 1 1 1 1. So when first clock, we will continuously feed 1 1 1 1 from the input side, from the inside. So for first down edge, the first flip-flop will have 1. For next down edge, this 1 on the flip-flop number 3 will get shifted to the flip-flop number 2. We are continuously feeding 1 1 1 from input side, that is D in, that's why we are getting 1 on every flip-flop left side. Then for next down edge, flip-flop 1 will now consider 1, and similarly for another down edge, flip-flop 0 will get value 1. So we require 4 clock pulses to store data. And what if you want this data which is already stored in this flip-flop out, then we require 3 more clock pulses to take this data out of this register. Okay. Now moving toward next register, that is serial in parallel out mode, SIPO. We have seen that we required 4 clock pulses to store data in serial out mode and 3 clock pulses to take data out. So, but in serial in parallel out mode, we require 4 clock pulses to store data, and we get output simultaneously. Let's see, if we have to store data 1111 when initially all flip-flop having 00, we will feed 111 continuously from the input side. So when first falling edge occur, flip-flop 3 will have input as a 1, and so as this output will be 1. So our final output will be 1000. Now when another next rising falling edge occur, the flip-flop 2 will have 1, and so as our output is 1100. When another falling edge occur, the flip-flop 1 will have 0 and thus our output will be 1111, and for next clock pulse or falling edge our output will be 1111. Thus we require 4 clock pulses to store data and serial in parallel out mode. Okay. Next is parallel in parallel out. This register is also called as storage or buffer register. Why storage or buffer register? Because we require only one clock pulse to store data. If we see, if we have initially 000 on each flip-flop, then and if we have to store 1111, then what? We have to feed 1111 from this B3, B2, B1 and B0, and when falling edge occur, all these flip-flop will get value 1111. So thus, we require only one clock pulse to store data. Then, moving to the next configuration, that is parallel in serial out mode. Parallel in serial out mode has a somewhat different configuration or different circuit diagram from the other shift register that we have already seen. We see that we have this another combinational circuit before the input of every flip-flop. Why this combinational circuit required is this flip-flop has to work in two different modes. First is a shift mode and next is a load mode. In load mode, we load data to each of the flip-flop, and in shift mode, we shift data from each flip-flop to our output side. Okay, we will see the working of this flip-flop. Let us consider the shift bit or load bar bit is equal to 0. So, one input of AND gate number 1, 3 and 5 is now 0. We know that if one of the input of AND gate is 0, then its output will be 0. So, the output of this AND gate number 1, 3 and 5 will be 0. Consider the AND gates 2, 4 and 6. We can see here that the input one input of these AND gates are 1, and we also know that whenever one input of AND gate is 1, its output will be the another input. So whatever data we will put in B0, B1 and B2 and B3 will be same come as an input directly input to this flip-flop, and when falling edge occur, this data will get stored in this flip-flop. So Q0 will get stored in flip-flop number 0, Q1 will get stored in flip-flop number 1, Q2 in flip-flop number 2, and since similarly Q3 in flip-flop number 3, and we will have output Q3. Now we will make the shift or load bar bit is equal to 1. Now this AND gate number 2, 4 and 6 will give us output 0, and AND gate number 1, 3 and 5 who's having their one input as a 1 and another input connected to the output of the flip-flop just before them. Therefore, this Q0 will get now connected to the D1, Q1 will get connected to D2 and Q2 will get connected to D3. When falling edge occur, the data present on flip-flop number 0 will get stored in flip-flop number 1, and data which was present on flip-flop number 1 will get stored in flip-flop number 2, and data which was present in flip-flop number 2 will get stored in flip-flop number 3. Thus, our data will get shifted. You can see here that for next clock pulse, flip-flop number 1 have 0, 0, Q0, flip-flop number 2 has Q1 and flip-flop number 3 has Q3. For next clock pulse, flip-flop number 2 will have Q0 and flip-flop number 3 will have Q1. And for another clock pulse, flip-flop number 3 will have Q0, and thus our data Q0, Q1, Q2 and Q3 which we have inserted in this register during load time is now out of the register. So that we require only one clock pulse to store data and 3 more clock pulses to take data out of this flip-flop. So, this is all about Shift Register. For any suggestion, please mail us at walchan.elisa@gmail.com, and don't forget to like us on facebook.com. Thank you.